All right, ladies and gentlemen, we're going to go ahead and dive into the warm-up. Again, if you want to bypass this, you don't have to have this in your notes, so feel free if you'd like to see one of these done. I know number one is a little tricky, number two is not terrible. So let's take a look. As you see, I want to simplify. I've got some big roots here, and I got one I need to rationalize. So I'm going to go ahead and break this down. I got 4 and 3, 2 and 2. That's 2 root 3. Negative root 27 breaks down 9 and 3, 3 and 3. I got a pair of threes. Don't forget about the negative. This is negative 3 root 3. And then this one right here, we need to rationalize, and we're going to multiply top and bottom by root 3. And now what I get is 5 root 3. And on the bottom, root 3 times root 3 is just 3. Well, if I want to combine all of these root 3's, I got to look at the numbers in front. 2 minus 3, and then plus 5/3. All right, you can do that in your head. 2 minus 3 is negative 1, and negative 1 plus 5/3 is 2/3. If you want to do that using, your calculator, you can, or how about just, if you need to do it by hand, get common denominators. I see that I have a 3 here, so I'm going to multiply top and bottom here by 3, and this one top and bottom by 3. So I'll go ahead and write up here. I get 3 times 2 is 6 root 3 over 3. That's the same thing as 2 root 3. And then I've got negative 3 times 3 is negative 9 root 3 over 3. That's the same thing as negative 3. And then plus 5 root 3 over 3. So I'll go ahead and add these up. 6 plus 5 is 11, minus 9, I get 2 root 3 over 3. So again, you can use your calculator. You can do that by hand. I know fractions are tricky. 5 out of 3 people struggle with fractions, but do your best and forget the rest. The last one here, I want to rationalize this denominator. This time I have a binomial, so I need to multiply by the conjugate, 2 minus 3 root 2. And whatever you do to the bottom, you got to do to the top to keep it equivalent. So go ahead and multiply by 2 minus 3 root 2 on top. So go ahead and distribute. Here we get 4 times 2 is 8. 4 times negative 3 is negative 12 root 2. And then we're going to FOIL the bottom. First, outers, inners, last. 2 times 2 is 4. Outers and inners, you don't have to write. They're going to cancel. But I'll go ahead and write them so you can see it. 2 times negative 3 root 2 is negative 6 root 2. 3 root 2 times 2 is 6 root 2. And 3 times negative 3 is negative 9. And root 2 times root 2 is just 2. I would probably simplify that in my head. Negative 9 times 2. Let's go ahead and make that negative 18. Again, this guy's going to cancel. And now I'm left with 4 minus 18 on the bottom. So if I write that down here, 4 minus 18 is negative 14. So if you got that, that's pretty good. But can we reduce the numbers on the outside? And if I look, 8, 12, and 14 all are reducible by 2. So go ahead and reduce by 2 or negative 2. If I reduce by negative 2, that's going to make this a negative 4. Reduce by negative 2 here, that's going to be a positive 6 root 2. And reduce here, that's going to be 7. All right, so again, 8 negative 14ths is negative 4/7. And again, this reduces by 2, makes it 6/7. Final answer. If you wanted to leave the negative on the bottom and have 4 minus 6 root 2 all over negative 7, you could do that as well. So there's your warm-up for today. And we're going to move on to solving radical equations, and that's our goal. As we look at these radical equations, we're going to follow these basic rules. First step, we're going to isolate the radical on one side of the equation. And then we're going to raise each side of the equation to a power equal to the index. And then we're going to solve. Okay. When we solve, make sure you check it. Okay. So this is what we have. When solving radical equations, the result may be a number that does not satisfy the original equation. Such a number is called an extraneous solution. I know that's kind of silly, but that's what they call it. So be sure to eliminate extraneous solutions by checking each answer. I'll remind that on a quiz or test, but and I'll show you a little trick here. but double check to make sure. All right, ladies and gentlemen, let's go ahead and get started. The first thing is step number one, isolate your root. In this case, I got the square root of y minus 2, and on the outside, I have minus 1 equals 5. Well, I want this root by itself, so I'm going to move this 1 over using addition. So I get the square root of y minus 2, and 5 plus 1 is 6. Step number two, we're going to raise each side to the equation of the power. In this case, to get rid of a square root, we're going to square both sides. And when I square a square root, it's magic. The square root just disappears. It undoes the root. And over here, 6 squared, we all know is 36. And the last step, go ahead and add 2. Add 2. End up with y equals 38. The last thing we do want you guys to do is check it, chia. And you can do this in your head. I usually do it right here, all right, where I've isolated the root, equal the number, and go ahead and plug in. 38 minus 2 is 36, and the square root of 36 is 6. So that checks out. Okay. We'll see one or two that doesn't. So let's do that same idea again. Step number one for number 2 here. Step 1, we're going to isolate this root. So we're going to take the square root of 2y minus 1 and get rid of this negative 3 by adding over. So we get the square root of 2y minus 1 equals 3. And now we want to do step number 2. We want to square both sides. Square both sides. Squaring undoes the square root, so the radicand falls out. It's like math magic. 3 squared we know is 9. We can go ahead and add 1. It gives us 2y equals 10. And go ahead and divide. And now I get y equals 5. Before I circle or box up my answer with these, I always check it. So look at this. It kind of looks like a check mark. So I always remind you guys, check it. So I'm going to go back to where it's isolated and go ahead and plug in 5. 2 times 5 is 10. 10 minus 1 is 9. And the square root of 9 is 3. So that works out perfect. So now I've checked it. There we go. I don't need to see the check, but it's up to you whether or not you get it right or not. All right, ladies and gentlemen, I'm going to come back to number 3. Let's go ahead and jump to number 4. We want to isolate this square root, so there's a couple things I got to do. Number 1, this is a plus 3, so I want to minus it over. And now I got negative square root of x minus 2 equals negative 3. And now the last thing is I got to get rid of this negative. Think of this as negative 1 times the root. Well, the opposite of times is divide by negative 1. Now I get root x minus 2 equals 3. Now to get rid of the square root, we square both sides. And I get x minus 2 equals 9. Go ahead and add that 2 over. And we get x is 11. Again, I like to plug it back in, assuming I did all this work right. Go ahead and plug it in, or you can plug into the original. Let's be crazy and let's plug it into the original. 11 minus 2 is 9. The square root of 9 is 3, and 3 minus 3 is 0. So I checked it. Now I can move on. Next one I want to do is number 5, because we're checking all these, and you're like, when would I ever see one that doesn't work? Well, here we go. If I subtract the 9 over, you see that I get the square root isolated, but now it's equal to a negative 8. And that's the key. When I square both sides, I get x minus 1 equals negative 8 times negative 8, or 64. Now I add 1. Final answer would be 65. But make sure you check it. When I go back up here and I check it, I'll put it in this one. I get 65 minus 1 is 64, and the square root of 64, is that negative 8? Oh no, oh no, 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 no. This is an extraneous solution. My trick to you is, or my help to you is, anytime you get a square root equal a negative number, then we know right away, no solution. If you get to this point and you want to go right to there, that's fine by me. You don't have to show me that work. Okay, just be careful. So this is not an answer. Does not work out. So those are pretty much the easy ones. It does get a little bit harder, like in example 6, and now I'm going to go back to number 3, when you see multiple roots, okay? So on this one, we have isolated the root, and now we got to square both sides. So when I square this side and when I square this side, the left side's pretty easy because I get x minus 12. But this side is a little bit trickier because when I square a quantity, we should have learned in Algebra 1 that we need to write it twice. And there's a little F word we say in math class. We call it FOIL. First, outers, inners, last. So let's go ahead and FOIL this thing. 2 times 2 is 4. 2 times negative root x is negative 2 root x. Negative root x times 2 is, again, a negative 2 root x. And a negative times a negative is a positive, and root x times root x is just x. From there, we can do some simplifying. And the concept is we want to go back to step number 1 and isolate this root. So let's clean up this side. Here I've got 4. Negative 2 root x and negative 2 root x is now a negative 4 root x, and then plus x. I'm going to bring this down now. Well, we want to isolate this root, so I'm going to go ahead and subtract this x over. And look at those cancel. Now I'm going to subtract this 4 over. Now look at, I get negative 12 minus 4 is negative 16. And now I got negative 4 root x. Well, isolate this guy. This is negative 4 times root x. Go ahead and divide by negative 4. Now I get 4 equals root x. We've isolated this root one more time, and now I can square both sides. And I end up with 4 squared is 16 equals just x. Or I prefer x equals 16. Before I move on and go to the next problem, I'll double check. 16 minus 12 is 4, and the square root of 4 I would get is 2. And over here, I get 2 minus the square root of 16. Well, that's 2 minus root 16, which is 4. The square root of 16 is 4. Is 2 equal to negative 2? It is not. That is not a solution. So I thought that I did all that work and I got that answer, but guess what? That's another extraneous solution. Doesn't happen very often, but that is an extraneous solution. Does not work. All right, ladies and gentlemen, we have one last tricky one. And again, these are more challenging because there are more roots here. This is where, again, we want to isolate one of these roots. Because this is root minus a root, because this is a minus in between, I would probably just go ahead and add this over. That way I'm dealing with positive roots. So now I've got root 2y minus 3. I've isolated that one. And now you can write this negative 1 plus or put this one in front. I'm going to go ahead and write this as 2y plus 3 and then minus 1. So I've isolated this root. Now we're ready to square both sides. This is where it's a little tricky because over here this is easy. This is just 2y minus 3. But over here, you, again, don't have to write it twice, but some people need to see it. When you have a quantity and you squared it, you have to write it as a quantity twice. So this is root 2y plus 3 minus 1 times itself. So this side, easy. This side, a little bit harder because we got a FOIL. First, outers, inners, last. So this is, here we go. So we're going to take our first turn. Root 2y plus 3 times 2y plus 3. I get, like, root x times root x is x. Root 2y plus 3 times itself is just 2y plus 3. Look at that. 2y plus 3 times negative 1 is now a negative 2y plus 3. Do it again. I got another negative 2y plus 3. Negative 1 times negative 1 is now plus 1. I would probably do a little simplifying here. This is 2y 3 plus 1 is 4. And over here, I have a -1 and a -1. When I put that together, now I have -2 root 2y plus 3. And I'll go ahead and bring this guy down. I'll go ahead and move these y's to the same side. Again, we're trying to isolate this root. The nice thing is these both cancel, and I'm going to subtract 4. Subtract 4, that gives me -7 equals -2 root 2y plus 3. Now I'm going to go ahead and divide by -2. Negative divided by negative is a positive 7/2, and that equals my root 2y plus 3. This is where I'm going to square both sides. Square both sides. When you square a fraction, you square the top and square the bottom. And I'm kind of run out of room, so I'm going to write over here 7 squared is 49, and 2 squared is 4. When I square a square root, I get the radicand, 2y plus 3. This is where I can go ahead and use my calculator or subtract this guy over. I'm going to go ahead and -3. This is where if you need a calc, go ahead and grab your calculator. I've got 49 fourths minus 3. Again, you got this guy, use it. Here we go, 49 fourths. Big minus sign 3 does it for you. It gives me 37 fourths. We're just subtracting 12 fourths. Okay, so I got 37 fourths equals 2y. The last thing we can do is go ahead and divide by 2. Go ahead and divide by 2. I want to keep change flip. My final answer will be 37/8. So this is where, if you want, and you should, go ahead and plug this back into the original. So this is what I'm going to do. I'm going to take 37/8. I'm going to plug it in right here for y and right here for y, where we have these roots, and see if it's equal to -1. So I'm just going to do it in my calculator here. I've got the square root. I've got 2, and then times. We got 37/8. And then I have -3. Press enter. That gives me 5/2. So I'll go ahead and write that on top, 5/2. Now I've got the square root of 2 times my fraction, 37/8. Again, I'm just checking my work. And now I'm going to do the +3. That gives me 7/2. So I got 5/2 minus 7/2. Is that equal to -1? You betcha, that is -2/2, which is equal to -1. So that checks. So I went ahead and checked it. Okay. Again, look how nasty this is. You need to get your root on the same side so you can square both sides. The left side's easy, the right side's a little bit tougher because you got a foil. Clean it up over here and then move stuff back over so that we can isolate this root and square both sides. Don't forget to check it. So ladies and gentlemen, this is the last ones for today. It says to undo a square root, you can square both sides of an equation. To undo a cube root, you can cube both sides. So when I see something like this, you have this 1/3 power. Understand that a 1/3 power is like a cube root. All right? Just like what we did up here to get rid of a square root, we square both sides. To get rid of a cube root, or to a 1/3 power, we cube both sides. So if you prefer to see this like this is a cube root of 3x plus 1. If you prefer to write it like that, you can, but you don't have to. So let's go ahead and isolate that root by subtracting 5 over. Now I get the cube root of 3x plus 1 equals -5. And now if I want to cube both sides to get rid of the cube root. So now I get the radicand, 3x plus 1. Now take -5 times -5 times -5, or -5 in your calculator cubed. And I should get -125. From here, I'm going to subtract 1. I get 3x equals -126. me go ahead and divide by 3. Go ahead and divide by 3. If I take negative 126 and divide by 3, I got negative 42. With cube roots, you can double check them. It is okay for a cube root to equal a negative. So if you want to plug it back in here, it is okay to get a negative. If I plug this back in, 3 times negative 42 is negative 126 plus 1. I would get the cube root of negative 125, which is negative 5. So it does check out. Again, any odd root equal negative is okay. All right, ladies and gentlemen, we're going to finish up with number 8 for today. I'm going to leave it as a cube root. So as I read this, it's 8 times this quantity, 3y minus 1 raised to the 1/3 power. I can't go ahead and multiply through. That doesn't work like that. So I got to get this 8 over on the other side so I can isolate this 1/3 power. It's kind of like a cube root again. So again, if I divide by 8, now I've got 3y minus 1 to the 1/3 equals 2. Now I'm going to cube both sides. I'm going to cube both sides. And that way, 3 times 1/3 cancels. That's why that works on number 7. Now I've got 3y minus 1 is equal to 2 cubed, which is 8. Now I can add 1. That gives me 3y equals 9. And now I can divide by 3. And now I get y equals 3. The nice thing is I can go back and check it. I'll probably check it right here. 3 times 3 is 9. 9 minus 1 is 8. And 8 to the 1/3 or cube rooted is 2. It works out. Okay. All right, ladies and gentlemen, that is it for Unit 5.4. Again, solving radical equations. Make sure you check it. Okay, these guys look like roots, so make sure you check your work. If you guys have any questions, let me know. Bye-bye.